everybody. Before I start talking about AI, I want to show you all a very simple thing. I have a pen in my hand, and if I drop it, it goes down. It's not any AI model that does it. It's not any logic that does it. It's the gravity at work. So what I'm trying to point is that there are fundamental laws that we have to deal with in the physical world. And this is also true for our electrification infrastructure. You know, Ohm's law doesn't care about the hype. Protection logics doesn't bend for anybody. They need to work whenever we need them to work, and they're always at play. So for our industry, AI has to be discussed differently. AI cannot hallucinate. AI has to operate within the guardrails of this system. So moving on. Whoops. We all know AI is really moving at an extraordinary speed. We see it every day in our coding environments as part of our communication workflows. And also, a lot of you are using them for your personal emails or chatbots as well. But in the industry, when I meet so many customers in last few days, they always were asking a question that, hey, when does it really become real? When do we get the real value in our substation because of AI? So this is what we try to answer. Yeah? In our world, you will not get the answer on how to improve electrification by a chatbot, but it is found where the power must flow reliably and safely. And I think it ends at the point that in industrial world, the AI cannot hallucinate, and it cannot invent a condition or a recommendation that is not grounded in the system reality. But our customers are also going through a lot. If I reflect back on what is happening to our customers, if you look at distribution utilities, they are getting pressure every day that we want to connect a new substation, we want to connect a new wind power plant, or we want more load from you. So they have this urgent and pressing need of transparency and capacity at scale. If you look at data centers, they have shown us a new thing in the electrical world, that there is a cost of downtime. Even a 1 second downtime can take or has a cost for them. And if you look at EVs, they are trying to scale this infrastructure across the world, you know, in the remote villages as well. So they are also creating this massive congestion in the network that needs to be solved. And not forgetting our heavy industries, they really are at the crossroads because A, we ask them to grow. B, they also have to decarbonize their power. But most importantly, they also have to work with the old infrastructure that they have. So they have a very complex and often aging asset infrastructure to deal with. So what it means is we have same sectors or different sectors, but same set of problems for them. And we are not going to solve this problem by adding new copper and steel alone. Yes, we need investments. Yes, we need new infrastructure. But we need to get much more performance from our electrical systems, from the existing grid infrastructure today as we speak. And we are at a perfect crossroads. We believe that AI is enabled by electrification. Yeah? You will have more data centers if you will have more power in region. And the GPUs do need electrons to get tokens running or inferences. But we can also use the help other way around. AI can also help electrification become more better and more smarter. So it is the beginning to improve the very electrical infrastructure it depends on. And this is what we are trying to explore as a team and with our customers on how this gets better. We believe that AI for industrial electrical grids is different because it's grounded in three things. Yeah? It's grounding it physical assets, the contextual operating data, and obviously the laws of physics, which are the fundamental laws. In our world, AI has to know the real equipment. It should know what is a transformer, it should know what is a switchgear, it should know what is a breaker, relay, feeder, or substation. Secondly, the data should be seen in abstract, not in isolated forms. You have to look at the operational data, you also have to look at the maintenance logs, you have to look at the event logs, and all of this is also sometimes disconnected. So AI has to actually go through those contextual data together. And third, which is the fundamental laws or the domain know-how, that's the real differentiator. In enterprise software, having a bug is annoying. In a CRM system, having a bug is annoying. But imagine having a bug when you are switching on and off power of a city. That's not possible. That creates a lot of safety risk for the people, for the economy, and it can also destabilize a lot of other things as well. So for us, the guardrails for the power system are very, very crucial. And that's what we are here to talk about. In our world, AI has to work with deterministic model, with protection principles, and with physical limits that you cannot run out. So we believe that the breakthrough for this AI or electrification industrial AI will come not just in building the foundation, but in a foundation which enables it. We believe that this will be done in 5 different layers. The first is sensing. That means you see, you observe. Second is interpreting layer, where you will interpret the data. Third is predicting the layer, where you start taking some guessworks of what can be happening next. Then comes optimizing, and last comes augmenting. So from the visibility to insight, from insight to foresight, from foresight with an ability to optimize, and then ultimately to augment the human decision making that we do every day. All the people, all the colleagues who work in electrical grids and power distribution sector, this is what they need. They need faster decision making to be done at scale without ignoring any set of data. And we also try to extrapolate a bit and think about it, that how AI will scale in electrical infrastructure. And we believe it will not create value in one place. It creates value in layers, and it creates value across the system. At the top, you see the progression, which is sense, interpret, predict, optimize, augment. First, the AI gives you visibility into the system, then it gives you the intelligence, then foresight and augmentation. But on the vertical axis, or the downside, you see where the value will be created. In electrical world, the value will be created in planning and operations, outages, assets, flexibility that we need. And that is important because opportunity is not a single pilot. It is an end-to-end transformation. The real takeaway in this is AI turns utility data into an operational leverage for all of the asset owners. So they move faster, they move better, and they move within the guardrails of the industry. I can give 2 good examples here. One is if you look at grid operations. I mean, from anomaly detection to switching recommendations. Yeah, today, if suddenly we have, for example, across Hanover Messe, 50 or 100 EVs coming in, there will be suddenly a peak load demand. How do you balance that? Which network you switch and how you switch? This is where grid can really help. The AI can really help because it can scan a massive amount of data in a fraction of seconds. And within the guardrail framework, it can actually give suggestions to the operator, hey, do this or do that. We do believe we will have human in the loop and human on the loop before we become autonomous. And there are pilots happening across the world where we are trying different autonomous systems as well, that these kind of switchings happen automatically. Second example, which is very close to where I'm from, customer service, is asset management. You know, we have almost 80 million kilometers of grid today. That's really huge. And if you count the number of electrical assets that we have, they are really in millions, whether it's from Siemens or from any other company. And not all the assets are connecting. They're not talking to you every day. You have to extract, you have to send somebody to the asset to understand the situation. And that's where I believe AI brings power. AI will be able to also understand offline assets which are not connecting, which are not giving you real-time IoT data by doing multimodal analysis like visual inspections as well. So imagine tomorrow there is a humanoid who's walking around in a substation just taking pictures, and with help of our domain trained or with our guardrails, inspection models, it is able to generate insights for the operators. Things we miss, small things like loose wires, yeah, or things like there is a dent or there is an anchor bolt missing, or probably we didn't read the report properly. So there is a massive amount of data that also gets ignored. So it really augments that as well. And it resonates with today's challenges of operations and maintenance. There is really a shortage of manpower. The way electrification is picking up, I can certainly recommend to any young engineer, opt for electrical sector, because the future is really bright and shiny there, because there is this huge demand. And what you have is, you will have in future the tools which can augment you and to make your life and jobs much more easier.